Okay, so good afternoon, everyone. So, as you might be knowing, that we'll be studying or doing some PYQs over Parabola. So, we had studied Parabola in our previous classes, right? So, this in this class, we'll try to solve some questions. So, for this class, let us start with the first question. And the other
Recording in
part
progress.
point it would be passing through is 5 comma minus 10. So, for that, we'll get the value of a here, right? So, let's take the value of a. N square is equals to 4 into a into 5. So 100 by 20 is equals to my A, and that is 5, right? And know what, and we know, right, what our focus is. Our focus is A comma 0, basically. Is it not? It is. So our focus is basically 5 comma 0, and that is our A.
Recording in progress.
This. So the points become as minus half and minus 2. So half is this, and this is minus 2. So this is what a parabola looks like, basically. Half and minus 2. And what do I have to find? The equation of directrix. So the directrix would be somewhat like this. And you have to find out A. So A is 1 here, as you can see from the standard equation. So the directrix become as x is equals to 1 by 2 plus 1. That is x is equals to 3 by 2. Are we right? Let us see the solution. Yes, it is x is equals to 3 by 2. See, I just upload this PDF for you guys also to go through, so you can like see the PDF and understand the solutions by step by step. I'm also trying to do some those solutions with each and every step, but sometimes I do skip some steps because the calculation part is quite easy. So don't mind that. If you have some troubles, you can also go through the solution that is given in the like this PDF. would just find
Recording
A
in
here, right?
progress.
And we can just solve it also. So what we can do is, yes, 81. Let's do the ratio part. So we have 2 times of 8 2 whole square by 5 is equals to A, right? And what do we have? 2 times of 281 plus 3 times of 282 by 5 is 0. So let us solve. This gives me 41 plus 62 is equal to 0. 41 minus 6 by T1 is equal to 0. So 41 is equal to 6 by T1. So T1 becomes root of 3 by 2, right? And T2 would be this. And I know the distances also, so I can calculate by this formula the value of A, right? Point of it, right?
Recording in progress.
So if we solve these two equations in terms of y or x, so we could get the midpoint very easily. Let us solve. So let me put the value of y here. So what am I getting? 2 times of a x plus x1 by y1's whole square would give me 4 times of a x plus b, and the whole equation would be in terms of x. So we can simply get the sum of roots here. Remember? So 4a square x plus x1's whole square is equals to 4 times a y1 x plus b, and I'm canceling the 4a, so I'm left with x square plus 2 times of x1 plus x1 whole square upon is equal to 4y1 by a into x plus 4, or b, it is b. Sorry, my handwriting, but it's b. And now taking the x coordinates together, so x1, I'm not taking x1 and x2 because that would be confusing, but the coordinates of xq plus xr becomes minus of 2, it would be minus of 2x1 and minus 411 by 8. This is what my sum of roots look like. And to take the midpoint, I'll just want to divide by 2. So dividing by 2, it gives me 2 1 this 2y1 by a plus, sorry, it would be a minus here, not a plus. minus x1. So this is my, what was I asked actually? The coordinate is the midpoint. So this is my coordinate 1. Where is, why is there a term of b here? I don't think there should be a b here. Let me just check it again. Maybe y1's whole square. Okay, let us see what we are doing wrong. Or just let me circle back to this question later on. I'll just circle back to this question later on. Let's move on to the next part because what I'm solving also is correct, but I think the question might be conveying something different. So let's leave it for the time being and move on to the next question. I'll get back to it. We'll do the question number 5. Okay, so what does question number 5 say? P is a point on the parabola whose ordinate is equal to its abscissa. Abscissa is me. Ordinate and abscissa is x and y coordinates basically. So ordinate is the coordinate and abscissa is the x coordinate. So it is given to us 81 whole square is equals to 281. So a and a gets cancelled, t and t gets cancelled, and what are we left with? T is equals to 2 or t1, whatever you want to take here. A normal is drawn to the parabola at P. It's meet again at Q. Okay, so let us draw this. This is my P, this is my Q, this is my normal, and here T is 2, the parameter T is equals to 2. Write it better. This is T is equals to 2. Okay, so if this is my S, so I have to get the product of slopes of this and this, right? So let us take it as a standard parabola. We can like really make it easy, but without applying the theory, or if you don't remember the formula, you can just take a normal parabola and get the points out. So for t is equals to 2, what am I getting? A is 1, right? So it's 4 comma 4. And now the norm and the tangent to this would look like y is equals to, so uh it is the tangents equation. What do we have as y is equals to 2x, x plus x1, right? So it would be 4y is equals to 2, a is 1 in this case. We've taken this as an example because it is not mentioned here. So we can apply it for any parabola. So x plus 4. So we'll cancel the 2 factor and I'm left with y is equals to 1 by 2 x plus 4. So the slope, this is the equation, and now solving it with the parabola again. So what
Recording in progress.
Okay, that might be the case for this. So it is 4 and minus 4. So I have to like get the slopes, and my this would be 1 comma 0. So the slopes would look like 0 minus of minus 4 upon 1 minus 4 into 0 minus 4 and 1 minus 4. So this gives me 4 into minus 4 is minus 16, and minus 3 into minus 3 is 9. So this gives me minus 16 by 9 as my slope. The product of slopes basically, not my slope. Okay, which is not the solution. So where am I going wrong? I got t is equal to 2, right? Fine. So we know the equation of the normal also now. Acha, the wrong part I did is I took the norm tangents equation itself. So that is wrong. Okay, so let's read
Recording in progress.
Acha, I had a mistake again, guys. What am I doing these days? I'm completely fine though. I'm telling you what's I don't know. So we are canceling the A, right? So I'm left with root 2 times and T is not in the root. So I forgot that part. 1 plus T square upon T square. So I'm left with 2 times of T square is equals to root of 1 plus T square. So it is 2 times of 2 to the power 4, 1 plus T square. And what am I left with? 2 to the power T4 minus T square minus 1 is equals to 0. And the valid root
Recording in
here, right?
progress.
If I take 1 here, so 2 minus 1 and minus 1 would give me 0. 1 is the root here. Why 1 is not a root here? So beta becomes half, 1 and half. So it would be minus half. And the product would be yes. So we have two roots, 1 and minus 1 by half. So T square cannot be minus 1.5, right? So T square has to be 1 and T becomes plus minus 1. So the two tangents that we have the slope of plus minus 1. And what do I have to calculate? Intersect the focus of the parabola. So the equation that I'm left with is y is equals to plus minus x plus minus a. This is my two parabolas that I have, sorry, two tangents that I have, and I have to intersect them at a focus. So this is passing through a focus, and these all are our standard parabolas, right? So let's first consider two questions. So it is passing through this also, right? X square
Recording in progress.
plus ax by 2 minus 2. Let me first erase the previous work and then get back to the new question. Okay. So this is what we have with us. And now, okay, just give me a minute. So what we can do is we can convert them into square, like in the perfect form and get our values out. And we'll do that only because that is the easiest way out.
Recording in progress.
Right? And this is my whole square. So this looks like x plus 3 by 4 is whole square minus times of this into 16, this into 16. 6 into 16 is 96 apparently. And 96 plus 9 is 105. So 105 by 16 a square. So I'll send it that side. So it becomes 3 times of I a cube plus 105 16 a square is equals to x plus 3 by 4 a whole square. And taking the 3 by a cube again common, I'm left with 3 times of a cube 105 16 by a square. The
Recording in progress.
parameter a. So let me just erase this first and then we'll go to the new question. Yes, we did this, right? Now we'll do the eighth question. We're done with 7 questions. We'll do the eighth question. Find the locus of the foot of the perpendicular drawn from a fixed point to any tangent to a parabola. Okay, so let us repeat that. We have a parabola, locus of a foot of a perpendicular. So let's take a fixed point, and that is the tangent to the parabola. So the foot of the perpendicular drawn from a fixed point to any tangent. Okay, so there is any tangent. I've drawn a random tangent, and I have drawn the foot of perpendicular from a fixed point. Let that fixed point be h comma k, and I have to find the locus for this. So we know what a normal parabolic tangent looks like. Y is equals to x by t plus 80. And now I'm dropping my perpendiculars from h comma k. So x by t minus y plus 80 is my equation, and the perpendicular coordinates I have to calculate, right? So what we can do is, if you want to, there are two ways you can go about it. You can like calculate the slope of the perpendicular, which would be equal to minus t, would be the slope of this, and it is passing through h comma k, so we know the equation of the line, and calculate the point of intersection, right? So let us solve. चलो अगर इतना मेहनत कर रहे हैं तो why not, let's solve. So okay, so let's go for it now. My equation is y minus k is equals to minus t times of x minus h. This is what my equation is. So y is equals to minus t times of x minus h plus k. And let's put it in the above equation. So what I'm left with, x by t minus, so let's minus and minus is cancelled. This is what I'm left with. And now let's get the x value out. So x has t plus 1 by t, then minus ht minus k plus at is equals to 0. So my x becomes ht plus k minus at by t plus 1 by t, and my y would become y is equals to x by t plus at, right? So my y would become h plus k by t minus a t plus 1 by t, and then plus at. So this is h plus k by t minus a plus at square minus a, or plus a by t plus 1 by t. So this and this is cancelled. I am left with h plus k by t plus at square t plus 1 by t is my y. So I have two equations in y and x, right? And I have to find the locus, but then I have, so what do I have here is I have to eliminate the a and t here. But how do I do that? There are two variables, right? Okay, I'm not getting this. This is something different. The elimination part I'm not getting, that how will we be eliminating a and t? Are they taking a also? They have taken a in their equation. So what you have to do is just you have to simply eliminate the t here. So ये दो equations है. We have these two equations, right? So what we have to do is we have to eliminate the t out of this, and you'll get your answer. So I hope you can do that by yourself. I'm really not getting into the nitty-gritties of it. It's easily solved, so I'm not getting into it. Let's move on. We have the ninth question. So let me erase the before part first, and then we'll do the ninth question. The tangents to the parabola at the extremities of a common chord AB of a circle x square plus y square is equals to 5, and the parabola y square is equals to 4x intersect the point T. Can we do just a different question? It's just getting over my head. Let's go to a different question. I'm really not enjoying this part. because it's a very basic question. They just had shown me the diagram also, so it really just diffuses your point of doing the question. So I really don't want to do this. Let's do something different. Let's do this question. No, not this one. This would take a lot of time. Okay, yeah, let's do that question only. Why just break the flow? I'm really sorry, guys. So what do we have here is the tangent to the parabola at the extremities of the chord AB of a circle x square plus y square is equals to 5, and the parabola's y square is equals to 4x intersect at the point T. Okay, so what does it say? We have the tangents to the parabola at the extremities of a common chord. So we have a common chord AB, and we have tangents from both of these sides. So this is done. Acha, so it is the common chord and it is passing through a circle also. So let's draw a circle. I'll just explain you the diagram, guys. I'm already like very much into it. I don't wish to draw my own diagram. So let's see. So basically, what do we have? We have a circle. This is a circle, right? And this is a parabola. So we have a common chord of both of these, and this is our common chord. So I'll erase this red part so you understand. This is the common chord, right? This is the common chord AB. And now we have tangents to the parabola at the extremity. So we are doing tangents here, right? Intersect at point T. So we have a tangent here and we have a tangent here, and they intersect at a point D. Square ABCD is constructed on this chord lying inside the parabola. Okay. Then we have to find out TC ka whole square plus TD ka whole square is equal to. So what they have done is they have taken basic geometry and taken the standard chord. So there could have been different chords, but they have taken a common chord. Okay, my bad, guys. So common chord is basically the chord of intersection between the circle and the parabola, and there would be a single chord. And since it is the standard parabola and a standard circle with the different radiuses or different parametric values. So what do we get is we get a vertical common chord. So if you see the diagram, a common chord, if you try solving also, a common chord would be 1 comma 2 and 1 comma minus 2 only. And if we draw a square, so we get our points, right? So we know the T also, we know D and C also. So it's very easy to calculate the distance. It's a very easy question, guys. I hope you get it. It seemed a bit tricky in the initial part with all the labelings and the things it was trying to do, but it is an easier question. Now let's do some more questions. Let's go for more advanced parts of the question. So let us see. Let us do the second question. I'm skipping the first one because it seemed a bit boring. So parabola is drawn touching the x-axis at the origin. Okay, so this is what the parabola would look like in a normal case. It could like have we had been turned to the negative side as well, but we have taken it as considering the positive side only, and having its vertex at the distance k from the x-axis. Okay, prove that the axis of the parabola is tangent to the parabola this. Okay, so let us solve. So first of all, we know that x-axis is the tangent to the parabola, right? So my is equal y is equals to 0 is the tangent to the parabola, right? Oh yeah. Yes. So sorry. Sorry for the interruption. So we have y is equals to 0 as a tangent to the parabola, right? And we have a vertex whose distance we are aware of. So what we can do is we know that the origin has been shifted here and it's a tilted parabola. So we cannot consider the equation to be like this. I'll tell you why. Because it could give you some problematic solutions, right? Since it is a tilted, it would be a tilted parabola, considering we can just change the axes here. So they have changed the axes and taken this. No, this is not the way I think we should go with the solution. I'll provide you a different solution later on, but not right now, because this is something that is out of the box. And being tilted parabola is always complex to solve. So I'll provide you a different solution later on, not right now. Let us see some other questions, some easier questions for the JEE means that we are prepping for. Okay, let me see some questions. So let us do this question. This is also a nice question. Seems like a nice question. So what do we have? We have a parabola, and we know its intersection points with the with a circle, a variable circle, as this is the circle, and we know its center is minus g and minus f, right? So its center is minus g and minus f, and it is intersecting at 4 points with the parabola y square is equals to 4x. So what do I have to prove? That y1 plus y2 plus y3 plus y4 is equal to 0. These are basically the coordinates here. These sum is equals to 0. So there is a very easy approach to this. What I can do is I can simply write x value is equals to y square by 4a and put it in the circles equation. So I'm left with x square by 16a square plus y square plus 2 times of g y square by 4a, and then I have 2fy plus c is equals to 0. And since there is not a single cubic term, right, this is a equation in power 4, right? It is a biquadratic equation and there is not a cubic term. So we know that sum of roots is basically, that is sum of roots is here y1 plus y2 plus y3 plus y4 is equals to negative of the coefficient at y cube, that's it, by the coefficient of y4. So here I have not a single term of y cube. So that gives me the answer that the sum is equal to 0, right? So let me just check with the time. Otherwise, we'll have to wrap up the session. So no, we are left with some more time. So let's continue. I'll take up last two questions or one question according to the question how lengthy it gets. So let's do this part. If we have consider a I'm doing the example 8. I'm reading the example 8. So consider a parabola y square is equals to 4x. The length of the focal chord is L. Okay. And the length of the perpendicular from the vertex to the chord is 3. Then. Okay, so let's take the standard case. See, easier way of solving this question is you take the standard focal chord a comma 0. This is a comma 2a. And this is a comma minus 2a. Right? So this, I know the length of the focal chord is equals to 4L. So L becomes 4a. And the length of perpendicular from the vertex is equals to a. So 4a to b. Basic question. This I got, but now I have to calculate the constant part. So that could be tricky, right? So let us take another example. And let's take t is equals to, this was t is equals to 1, right? So let's take t is equals to 2. So what am I left with? If I take t is equals to 2, so it is 4a comma 4a, and then it would be minus 1 by t. So minus a by 4. No, it would be a by 4, not minus a by 4. It would be a by 4, and it would be minus a because I'm taking minus half, right? So this is what I get. So I know the length of the chord would look like 4a minus a by 4 ka whole square plus 5a ka whole square, and this would give me 15 whole square's root. This is my L, and now the perpendicular distance, right? So let us see the perpendicular distance. Let me calculate the lines equation. So this is equal to, okay, so what do I have? Y minus 4a is equals to 20a by 16, right? It's 16 minus 16 minus 1 is 15a. So this is 15a by x minus 4a. So a and a gets cancelled, so it is 4 by 3. I'm left with 3y minus 12a is equals to 4x minus 16a. So it is 4x minus 3y minus 4a is equals to 0. And its distance from the origin would be 4a by 5, right? So if I solve this, so 2 to 5 a square plus 25 into 16 a square and then root over 4. And I have to multiply this, right? So 2 to 5 into 25 into 16 is 5 into 4 is 100, and 100 into 4 is 400. So this is 400. So this gives me 625, and 625 root 2 is 25. I'll erase it. 625 is 25a by 4 into 4a by 5. So I'm giving a product, right? So this gives me 5a square, which is not equal to 4a square. So their product is not constant. So let's get back to the question. So their product is not constant. So it could be L square into P, that is a constant here. Let us check the solution that they're giving us. It is LP square, that is a constant. Okay. So we got our answer. It's an easier way to solve, right? You take a standard equation and take the other case, so that makes very easy, not going through the whole process of eliminating coefficients. I know sometimes it would give you a shorter answer and this calculation can seem lengthy, but if you have a strong hold of calculation and doing the calculative part, you might enjoy this, right? So it's completely dependent over you. Here also we can just go through the solution what they're trying to do. They have taken an arbitrary t and they're solving with the t and trying to eliminate the t then. So that is where it can get a bit murky to remove the a or t from the equation. So I hope you get it. So let's just end this session here, and we'll try to solve more questions over the conic. And I hope the parabola part seems more clearly to you guys. So thank you. I'll see you in the next class.